Hello, hello. Is this working? Yeah. Okay. Yeah. All right, so we're doing compounded interest rates. What does that mean? Let's find out. This has to do with e to the. All right. We're doing compounded interest. Don't forget tonight's homework, page 336, multiples of 10. Some of you need a lot of homework checks, and there's not a lot left, so get on it. All right. So what if I have a principal of $1,000, and my interest rate is 10%? How much interest do you get at the end of the year? Now, I'm saying simple interest once a year. $100, right? All right, so usually what we say is the principal, the interest that you get is your principal times your rate times your time. The principal is 1,000. What's the rate? 0.1. You got to write it as a decimal, right? 0.1. And I'm saying over 1 year. So that's $100 of interest. So your new principal is $1,100. Yes? Okay. That's simple interest. All right. But nobody goes to a bank that gives them simple interest. You have some kind of compounded interest, either discretely 2 times, 4 times, 6 times, 12 times a year, or continuously every moment of every second, of every minute of every hour of every day. What does that mean? All right, let's use the same idea. But what if the time is less than 1? What if you get interest every half a year, or every quarter of a year, or every 12th of a year, every month, right? All right, so this is compounded interest. Let's say, again, for argument's sake, your principal is $1,000 and your interest rate is 10%. Okay, shh, listen up. Okay, you got it? Oh, okay. All right, but now I get interest twice a year. Okay, I'm getting interest twice a year. So what does that mean? Well, my principal is still $1,000, and my interest rate is still 0.1, right? But I'm taking only half of a year. We're going to see if that has anything to do with E. Yes. This is where Euler discovered E. That's why it's called E, Euler's number. Euler starts with E, the name Euler. All right, so how much money is that? Now, half a year is what? How many months? 6 months, right? So every 6 months you're going to get money. So what do you get the first 6 months? What's half of 10% of 1,000? 50, right? Because we already said 10% of 1,000 was 100. Okay. Now, what's nice about compounded interest is that the principal is changing. You only put in $1,000. You're not putting in any more money. But the next time they give you interest, it has to be based on 1,000 plus the 50 that's now in your account. So you're getting interest on interest on interest. So it gets bigger. This is good. So we're still getting 10%, but only for half a year. All right, so what's 10% of anything? What's an easy way to get 10% of anything? Huh? Chop off the 0, or move the decimal once to the left. So 105. What's 105 divided by 2? 5250, right, okay. So now I don't get 50 again, I get more than 50. So altogether, I ended up with $102.50 plus the $1,000 we started off with. That's my new principal when I'm done. So instead of $1,100, simple interest, right? The final principal here was 1,000 plus 100, right? Instead of simple interest giving you $1,100, compounded interest compounded twice a year or semi-annually gives you $1,102.50. So can you get as much as you want? It seems like I can get more. Can I get more? What if I do it 4 times a year? How many months is that? 4 times a year? Every 3 months? Okay. What if I do that every 3 months? Let's see. Let's try it again. What if your principal is still $1,000, just for the sake of argument, for comparison's sake? Your interest rate is still 10%, okay? But now you're going to get interest 4 times a year, okay? All right, listen up. Shh. Now you're going to get interest 4 times a year. So 1,000 is your principal, $1,000. 0.1, 10% is still your interest rate. But how much of a year are you doing this? A quarter, half of a half. A quarter of a year, every 4 times a year, a quarter of a year, every 3 months, right? So let's do it. Let's see what we get. Interest 1 after 3 months. Interest 2 after 3 more months. Interest 3 after 3 more months. Interest 4 after all 12 months, right? Your principal is still $1,000. Your interest rate is still 0.1. But the amount of time you're putting this in the bank is only 1/4 of a year, right? So what's 1/4 of 10% of 1,000?
12.5.
You went 1/8. 25, right? Because remember, this 10% is just 100 divided by 4 is 25. Okay. Now, look what we're doing. 1,000, what should I write here? 1,025 times 10% divided by 4. Well, what's 10% of 1,025? 102.5. And divide that by 4. Well, that's starting to get to be a bit of a pain, right? So that's what Ziggy's for. All right, wake up. All right, so it's 1,025 times the 0.1 divided by 4. And now you get $25.63 because the bank is obligated to give you dollars and cents, right? So you got to round off to the nearest cent. And they're going to round off in your favor. If it's 62.5, they got to give you 63. Okay, so if we're rounding off, it's $25.63. But what should I write here? 1,050.625. I want to be as accurate as possible. This is really how much I have. Times 10% times 1/4 of a year. Now what do you get? Well, let's find out. Let's add this to 1,025. Okay. Let's multiply that by 0.1 and divide that by 4. Now it's 2627, right? Now, look, there's going to be lots of round-off error going on here. I really want to avoid this. Right? This is not a good way to do this. So I'm going to do it this way. I'm going to say this. Aren't I really doing 1,000 times 1 plus 0.1 divided by 4 to the 1 to the 2 to the 3? Isn't this the same thing? This is the exact same thing. All right? So the difference being here, I'm just writing out the interest. Here I'm also including the principal, the $1,000 that I started with. So 25 plus 25,625 is 5625. Plus 26 to whatever it was, I forget what it was, is 7689 something, right? So the final result is going to be, do that 4 times a year. And you end up with a final principal of $1,103.81. All right, is that the most you can get? No. You can get more. Yeah. Okay, the 1, all right, what if I distribute? What's 1,000 times 1? 1,000. And 1,000 times 0.1 over 4 is what I'm doing. So what this is doing, it's doing more than just getting the interest. It's adding on the $1,000 that we started with. All right? So each one of these starts with 1,000 plus whatever. Right? Right. This is better. Okay? So what are we saying? That in general, your principal over T years is the initial amount, P0 is the initial principal that you have, times 1 plus the interest rate over N to the NT. What does that mean? N is the number of compoundings, like in this case, 4 times a year. And NT is the total number of compoundings altogether, including T years. Yeah.
1 plus T over N.
1 plus R, the interest rate. That's R. That's an R, okay? Yeah. And the N is the number of compoundings per year. Yeah. P sub 0, initial principal. At T equals 0, right? Before you start. Yeah. That's a plus. All right, so what I'm doing is I'm trying to organize this in a way where we're going to avoid the round-off error, okay? So take the initial principal times the quantity, 1 plus the interest rate, like 0.1, over the number of compoundings, say 4, to the 4 times the number of years, okay? Now the question is, what's the most you can get? Because we started with $1,100, then we had $1,102.50, then we had $1,103 and something, right? What's the most you can get? If I take 1,000 bucks times 1 plus 0.1 over n to the n, where t equals 1 year. I'm just saying 1 year, okay? What's the limit as n goes to infinity? My n's are inconsistent. What's the limit? How big does that get? All right, that's what limit means. As n gets really, really big, as the number of compoundings gets 2, 4, 12, 5 million times a year, whatever it is, what's the most I can get? Let's find out. Well, yeah, but sometimes you get a number. Sometimes you get a limit. All right? So let's work this out. What if I do, or what if I do this? 1,000 times 1 plus 0.1 over 1 to the 1. What was that? How did we get that? We originally got that when? That was our first answer. When? You're getting 1 compounded, where you're getting interest at the end of the year. That's it, okay? Now I'm making this easy. I'm making t equal to 1. 1 year. N is the number of times a year you're getting interest. So if n equals 1, n is 1, n is 1, n is 1, n is 1, right? 1 times a year, simple interest, you get $1,100. All right. What if I double that? What if I do it twice a year? Didn't we get that? We did that by hand. $1,102.50. We did that, right? Right? Remember, we started with 1,100, 1 times a year. Then twice a year, we got $1,102.50. That's shorthand for the same thing. Okay. Then if we do it 4 times a year, we ended up with this. Let's see. Put a 4 here. Put a 4 here. And you get that. Go away. Right? You get that. Okay, good. So what's the most that you can get? Notice what I'm doing. Once, twice, 4 times. I'm doubling it every time. What if I do it 8 times a year? How much money am I going to get now? I get interest 8 times a year. $104.49, say, right? Okay. What if I double it again? What if I make it 16 times a year? $104.83 if you round off to the nearest cent. So what's the most I can get? How about 32 times a year? Oh, whoop, that's wrong. 32, 32, 32. All right, so we're up to almost $1,105. Well, actually, it rounds off to $5 if we round off the nearest cent. So what's the most you can do? What if I do this 100 times a year? Is that more? Yeah, 12 cents more. Okay. What if I do this 1,000 times a year? Did we get more? $1,105 and 17 cents? What's the most I can get? Let's see. Let's do this 10,000 times a year. It's still 17 cents. It's a little bit bigger if you don't round off, but when you round off, it's still $1,105.17. Sounds like that's about as much as I'm going to get. Let's see. Let's try this again. How about 100,000 times a year? You want to go to $1 million already? Well, that's next. But did that change? It changed a little bit. It's still to the nearest cent. It's still the same, but it still changed. This part changed a little bit. All right. So what I'm trying to say is that you either have discretely compounded interest, or you have continuously compounded interest. As it turns out, as n goes to infinity, you get this. You ever hear PERT? Right? That's compounded continuously. Every moment of every second of every minute of every hour of every single day, you're getting interest all the time. And the most you can get, it looks like it's this, right? Let's see. What is 1,000 times e to the 0.1? times, whoops, 0.1 times 1 year. I'm still just doing 1 year, right? We almost got there. All right, so as n goes to infinity, the number of compoundings you get PERT, okay? So you have discretely compounded interest, and you have continuously compounded interest. Discretely means once or twice or 6 times or 12 times a year. Continuously means infinitely many times a year. But still, even though you're getting infinitely many compoundings, you don't get infinite bucks, right? There's a limit. That's as much as you're going to get. That's as much as you're going to get. That's what Euler did. He worked out this limit, and he found out what E was. And since Euler is spelt they named Euler's number after him. They named it E. All right? Euler. Okay? EU is a diphthong. A diphthong is a made-up variable, vowel made up of 2 other vowels. If you speak German correctly, how do you say Europe in German? Europa. EU. Where do you think oi comes from? Yiddish. Okay? So yeah, that's how you say Euler. Wo ist Spanien? Spanien ist in Westeuropa. All right, anyway. So, what we're saying is that the limit, as n goes to infinity, of p0, 1 plus r over n to the n, t is p0 e to the rt. So let me ask you this. How do you calculate e? Based on that statement, how do you calculate e? Well, right. The p0s are the same, and the t's are the same. So what if I write it this way? As n goes to infinity, get rid of the p0 and the t's. Just say this. 1 plus r over n to the n equals e to the r. Now, what if I just want e? I want to calculate e. No. I want to calculate e. So I don't want e to the r. I want e to the what? 1. So if r is 1, yeah, my n's are looking weird. Hang on. Yeah, it's n like okay, n goes to infinity. All right. 1 plus 1 over n to the n, that's the definition of e. That's e. Okay, are you ready? Let's calculate e. This is how you calculate e. What if I graph that? Go to y equals. Oh, there it is. Instead of n's, I got x's because in function mode I got to use x as a variable, right? What if I graph that? Zoom 4, let's say. Now that's a weird graph. I'm graphing this, right? I'm graphing this, but I made x here and x here so I could use function mode, right? Now I'm only interested in large n's. I'm not interested in negatives, am I? What if I start at x min is 1 and x max is, say, 100? Okay? So 1 being once a year compounding, right? 2 being twice a year compounding. 4 being 4 times a year compounding. Same thing, right? What does this graph look like? Don't you see a horizontal... Don't you see a horizontal asymptote here? And that's the limit. The limit is that y value. What is that y value? What is it approaching? What is it getting really, really, really close to? Let's find out. I want to see what that does as x gets humongous. All right? So let's figure it out. What is vars, y vars, function 1 of 1? Of 10? Of 100? Of, whoops, 1,000? Of 10,000? Of 100,000? Of 1 million? I wrote that as y1. How do you get over here? Okay. You go vars, y vars, function 1. And we were up to like, what was it, 100,000 already?
That equals 3.
You think it's going to be 3?
No.
And then here's 1 million.
3.
And here's 10 million.
It's really getting frustrating.
It's still changing, right? Once it stops changing, that's the limit. Okay, 100 million. Wow. A billion. Well, they're pretty darn close. It's off only by these two digits here. How about 10 billion? Yep. How about 100 billion? And once it stops changing, it's not going to change anymore. Even if I throw in a million more zeros, doesn't matter. So that limit is 2.718 something. That's E. That's what E is. You can, but I'm saying that's where it comes from. E is about 2.718. Right, that's a limiting process. Okay? No matter how big n gets, y doesn't get bigger than that. No matter how big x gets, the y value never gets bigger than that number. All righty? All right, so take a look at some questions from the homework page. Page 336, number, I don't know. What's a good one? 11. Yep, page 236, multiples of 10 tonight. All right, here we go. Page 336, number 11. All right. It says, well, let's see. What does it say? It says, find the principal needed now to get the given amount. In other words, find the present value. So I want to get $100. I want my account to be $100 after 2 years at 6% compounded monthly. I'm going to keep my money in the bank for 2 years at 6% compounded monthly. All right, so compounded monthly, is that compounded discretely or continuously? Discretely. Monthly would mean how many times a year? N equals 12, exactly. All right, so let's do that. So we're using this statement. All right, now they're saying, how much money do you have to put in now to end up with $100? Where does 100 go? In front, right? That's your future value. If this was like a finance course in college or business class, right, they would call that the future value. And P0 we're solving for is the present value. How much money you got right now to put in the bank, right? All right, now, they said that you're investing this at 6%. What's R? 0.06, 6% over 100. And you're compounding this monthly, so N is how big? 12. And you're doing this for 2 years. So N is still 12, but T is 2 years. There you go. So, right, so to the 24th. So how do you solve for your present value? How much money you got to put in the bank now to end up with that much money in 2 years? How to get P0 loan, in other words? How to get P0 loan? No, it's not adding. It's multiplying, so how to get rid of it? Divide. So take the 100 and divide it by all that mess. 1 plus 0.06 over 12 to the 24th, isn't it? Let's see what that is. So 100 divided by the quantity, 1 plus 0.06 over 12 to the, 12, to the 24th. You did it right. And you should invest right now how much bucks? 88 and 72, right? Because it's cents, dollars and cents. All right, so you have, if you invest $88.72 now at a bank that gives you 6% compounded monthly for 2 years, you'll end up with $100 after 2 years. All righty? Bucks. B-U-X. All right, take a look at number 9. Number 9 says take $100 at 10% compounded continuously for 2.25 years. How much money do you get? All right, so you have $100, okay, at 10% interest for 2.25 years compounded continuously. So which formula am I using, the first one or the second one? The second one, compounded continuously. They said it. They say the word continuous, you do this. Yeah? Yeah. You can actually do this. All right. So this is number 9. We're using future value is present value e to the RT. That's an E. Okay. All right, so they said you're investing $100. Where does the 100 go now? This is future value, this is present value. I have $100 to put in the bank right now, so present value right here. At 10%, so what's R? 0.1. For 2.25 years, so that's 2.25? Okay. and that's going to be your future value after 2.25 years. So let's find out what that is. Do it on a calculator. Here we go. 100. How do you get e to the second ln? All right, of 0.1 times 2.25, and you get $125.23. Well, you're not going to get 10% nowadays, so that's pretty good, actually. Okay. All right, so try that again. How about number 29? 29 says, how long does it take for an investment to double if you invest at 8% a year, compounded monthly? How long does it take to double your money? All right, now we're doing this, what was it now? Monthly. This is 29. All right, so if we're doing this monthly, which formula am I using, the top or the bottom? The top, monthly. And N is? Then N is monthly? What does monthly mean? N is? 12. Okay. All right, so this is what we're doing. 29. So we're using this statement. Okay. Now, they said you have this investment at 8%. So what's R? 0.08. And you told me N is monthly means 12. Okay.
The other end's 12 too.
Okay. And the other end is 12 too. All right. Now what we're really what we're solving for this time is not P0 but T. T is the amount of time it takes to double your investment. So whatever, I don't care what you put in, $1,000, $100, whatever you put in, I want to end up with double that. So whatever it is, I end up with what? If I start with P0 and I want to double it, I end up with what? No. If this is 100, I want to end up with 200. If this is 1,000, I want to end up with 2,000. So if this is P0, I don't care what it is, it's going to be 2P0. Right. So how do you solve for T is the question. Divide by what? By what? By what? How do you get T alone?
Stuff in the parentheses.
Stuff in the parentheses? Well, that's just a number. You can actually figure that out. Whatever that is, that's just a number.
It's 2PO raised to 12. Right?
Not yet. You're ahead of me. How do you solve for T? Well, notice P0 is on both sides. Can't you just cancel it? Okay. So this is the doubling time right here. This is what's called the doubling factor. Okay? When this equals 2, you double your money. This is called the doubling factor. I want to solve for T, the doubling time. So continue. What's the next step to get T? Now remember, what's weird about this is that it's an exponential equation. The variable is in the exponent. How do you deal with that? Not raise, it's already raised. How do you get rid of exponents? Well, if it's just a number, you could radicalize it, yes. If it's squared, you square root. If it's cubed, you cube root. But it's 12 times t, it's more complicated. How do you simplify an exponential? Where were you all week last week? You can do logs, right. Now, I don't care which log you use. I'm going to use ln. It doesn't matter. All right, so let's say take the ln of both sides. The ln of 2 equals the ln of the stuff, right? But what do logs, why did you do this? What do logs do to exponents? What's a log rule for powers? This is a power, take the exponent and put it in the front, right? Okay. So ln of 2 is 12t times the ln of 1 plus 0.08 over 12. All right, you're almost there. How do you get t alone? Divide by 12 and divide by the ln, right? So I got to get t alone. So divide by 12 and this stuff. It's just a number. So t is ln of 2 divided by 12 and the ln of 1 plus 0.08 over 12. All right, so let's figure that out on the calculator. What's the doubling time of this investment? All right. So let's see. ln of 2 divided by 12 and divided by the ln of 1 plus 0.08 divided by 12. 12. Where's the 12? All righty. And that's that. Boom. So the doubling time is 8.693 years, roughly. 8.693 years. That's a doubling time if you have 12 compoundings a year, discretely compounded monthly interest. Yes? All right, that was part one of the question. Part two of the question is how much better is it if you use continuous compounding? Instead of using compounded monthly, discretely compounding the first function, what if you did the same problem with continuously compounded interest? Would you expect that to take longer to double your money or shorter amount of time? Shorter, that's the idea. So let's find out how much shorter. So this is 29, right? So instead of using this, we're going to use PERT, but we're going to do the same stuff, okay? So now we're going to use PERT. Future value is present value e to the RT, okay? All right, so listen. So R is 8%. How do you write R? 0.08. Again, T is what we're solving, so leave it. Okay. I don't care what the initial deposit is. I want to double it. So what goes here? 2 P0. So right away the P0s cancel. So 2 equals e to the 0.08 T. Now, how do you solve for T? You're going to use ln again. And ln is nice here because it's going to cancel the e to the right away. So I write ln of 2 equals what? 0.08 T. How to get T alone? One more step. Divide. So T is the ln of 2 divided by 0.08, which is, let's see what it is. Ln of 2 divided by 0.08 is, oh, I just wrote it wrong. Where's the 0.02? Clear. Ln of 2 divided by 0.08, did I do it right? Yeah, is 6.664 years. Well, is it less than last time? 8.664 years. Last time we said, what the heck did we say? 8.693. Now we got 8.664. Well, it's less, not much less, but it's less, right? Compare 664 with 693. It's a little bit less, right? So compounded continuously gets you more money faster. The doubling time is shorter. Okay. All righty. What else we got here? All right, take a look at 21. Any questions on 29? Notice we did 29 two different ways, right? With discretely compounded interest 12 times a year and continuously compounded interest, right? Mm-hmm. What's nice about an exponential function is that the doubling time is always the same. Or the half-life is always the same. You ever hear of half-life? What if I have a radioactive substance? I have 1,000 grams of it. I have a kilogram, right? And the half-life is 10 years. What does that mean? That in 10 years I end up with 500 grams, half of it, right? But 10 more years I end up with half of that. So you add 10, you add 10, you add 10, but you have, right? So I start with 1,000 today. 10 years, 500. 20 years from today, 250. 30 years from today, 125. 40 years from today, 62.5, and so forth, right? That's the half-life. Same thing happens in your bank account. Your doubling time. Now, this doubling time was 8 some odd years. Let's make it easy, 10 years. Let's say you put $1,000 in the bank, and it doubles every 10 years. So you have $1,000 today. In 10 years, you have 2,000. 10 more years, in other words, 20 years from today, 4,000, right? 1,000, 2,000, 4,000. 10 more years, 30 years from now, 8,000. 40 years from now, 16,000. 50 years from now, 32,000, and so forth. The doubling time is a constant in your exponential curve. Okay. All right, so 21. Find the effective rate of 5.25% compounded quarterly. Okay, what does that mean? All right. Here's 21. All right, now compounded quarterly, is that this equation? Or is it this one? I want to compound quarterly. Which one do I want? The first one, okay. All right, not only that, they're saying that your interest rate is 5.25%. So, what's R? 5.25%? How do you write 5.25%? 5.25 is 5.25. Now percent? 0.0525. All right, so this is 0.0525. And we're compounded quarterly, so n is 4. To the, get this out of the way, to the 4t. Okay. Where's the thing? Okay. So that's where we're getting. Now, what they're asking you to do is to compare that. What's your effective yield? Compare that to simple interest. How much more money are you getting than if you had simple interest? Now, simple interest, remember, is simply P0 times 1 plus 0.0525 over 1. Simple interest means you're getting interest at once at the end of the year. So you want to compare these two amounts. Wait. You're comparing these two amounts. The question is, what interest rate do you have to get at a bank that gives you simple interest to get the same amount of money as this bank? That's what they're asking. What's the effective yield? So how do you solve for R? How do you make these equal? So these are equal. How do you solve for R? The P0s cancel. The T's cancel. You have to say this. So solve for R. Figure that out in the calculator, subtract 1. That's it. All right, so don't forget, multiples of 10 on page 336 tonight. Take a look at that tomorrow. All right. Page 336 tonight. There's not a lot of homework checks left. You're going to want to get started if you haven't done so already. Yeah, work this out on your calculator and then subtract 1 and you're done. Yep.
All it is just really figuring out what it is, multiplying, plugging in, and the only thing really is just determining the rate. And when you have the rate, just remembering if it's semi-annually or quarterly, annually, or whatever, just whatever. That's it.
That's it. All right, bye-bye.